Now come here. So I've explained about the source netting, destination netting, and twice netting, whatever it is. Now we are going to know types of netting. Okay, what are the actual types of netting? So here is basically there are three types. Basically there are three types. I'm using a word basically. There are multiple types also, but mainly is three. Okay, I will explain for 2-3 other types of firewall after that. But basically it has a three types. One is static NAT. One is static NAT. Second one is dynamic NAT. And third one is dynamic PAT. Okay, these three. We will learn about these three. There are some more is there. I will explain later on. Okay. So these are the important, very important NAT. Okay. And all rest of all are following their features only. So now what is static NAT? Static NAT is a one-to-one netting. Static NAT is a one-to-one netting. One-to-one netting. It means one-to-one netting means what? Like I have one PC 10.0.0.1. I have NAT to this IP 1.1.1.1. Okay. So it is means it is NATed, but it is kind of a binding together. Okay. And static NAT is a bidirectional. Static NAT is a bidirectional. What does it mean bidirectional? I will explain right now. So just learn static NAT is a one-to-one netting and it's a bidirectional. Simple. So it means what? Like I have one firewall and I have one internet and there is a one PC and I have a one PC at inside zone. Okay, guys, PC1, PC2. The IP of this PC is 10.0.0.1 and IP of this is 2.2.2.2. Okay, so I have natted my this PC of 1.1.1.1. Okay, so I have natted it. So it is not yet that it is binding together. Okay, so no other IP, no other PC will use this public IP. Only this IP 10.0.0.1 is only use this IP. That's it. It's restricted. Only this IP is going to use all the time 1.1.1. It is binded together. Got my point? Okay, this 10.0.0.1 is permanently natting with 1.1.1. So this is a kind of only single PC can able to use this IP 1.1.1, this public IP. Okay, so that's why this is natted with only one PC. That's why it is bidirectional. It means when this PC will initiate a connection to going to this public, okay, even though in such in other scenarios, if this PC will also initiate a traffic to 1.1.1, it will directly come to 10.0.0.1 IP. Okay, so it is bidirectional. Why? Because it is 1.1.1 is publicly statically natted with this IP. It means it's well known that whenever any traffic will come to 10.0.0.1 at the firewall, it will automatically all the time send to 10.0.0.1 PC. That point is clear, guys. Static NAT is static NAT. It means it is binding to one IP, one-to-one netting. That's what I'm using the term. It is one-to-one netting. It means this PC is binding with this IP. So whoever even from the outside, if anyone initiated traffic to 1.1.1, the traffic by default coming to this one because it is binding together. Okay. One-to-one netting. So here, like I'm giving one scenarios. Okay, like same thing. We have a firewall. There is a one internet PC, and this is my inside zone 10.0.0.0.1. It is statically netted with 1.1.1. Statically netted. Okay. So here, what is my original packet? If this PC1, when this PC1 will initiate traffic, what is my original packet here? Original packet. Source IP is 10.0.0.1. Okay, destination IP is like same 2.2.2.2 and translated packet source IP 1.1.1 and destination IP is my same 2.2. So this is for when traffic will initiate from inside to outside. Okay, like suppose in the same scenarios, if initiator is which means traffic initiating from the outside. This one is become initiator. Okay, this one is initiator. That time, what is my original packet, guys? Source IP is 2.2.2.2 and destination IP is 1.1.1.1. Translated packet source IP is and destination IP is changed to 10.0.0.1. That is clear, guys. Okay, that is what is static NAT. So it means in static NAT, traffic is bidirectional. What is the meaning of bidirectional? Means traffic not only initiate from the inside, it can also be initiated from the outside. Okay, guys, you will understand this phenomena once I will explain the other two types of. Okay, so it means it is binding together. So for binding together, even from outside, guys, if initiate traffic to this 1.1.1.1, the traffic automatically will send by the firewall to this PC. You'll understand it later on. Okay, but guys, please concentrate on original packet and translated packet. So this is the static. Okay, so now I'm going to explain the dynamic NAT. Okay, dynamic NAT. Dynamic NAT is kind of a pool. It's kind of a pool of a public IP. It's kind of a dynamic NAT is a pool of public IPs. Okay, pool of public IP where public IP will initiate, where public IP will assign to private IP. Where public IP will assign to private IP. private IP, and it is used first FIFO. What is FIFO? First come first serve. First come first serve features. I will explain what is it. Okay, so it has a some pool of public IP. Okay, guys. So like I have a subnet, I have a PC, I have 1, 2, 3, 4. I have a 4 PC, PC1, PC2, PC3, PC4, and I have even some pool of public. So whenever this all 4 PC will go outside, we have a one pool. I have assigned some pool of public IP. Like I have assigned a 3 public IP. Okay, we have a 4 private IP. Like IP of this PC is 10.001, 10.002, one is 10.003, other one is 10.0.0.4. Okay, these are my 4 PC. Whenever if they are going to the internet, I have assigned for those pool, for those PC, I have assigned 3 public IP. 1.1.1. Okay. Second one is suppose 3.3.3. Suppose 4.4.4.4. Okay, let's get example. We have a 4 PC only, 4 PC, and we have a 3 public IP. So dynamic NAT is a pool, like a group. Pool means what? Group. So in the group, we have given a 3 public IP. Whenever those 4 users go outside, it will assign one public IP. So like I'm just explaining here. Okay. So just like we have a 4 PC, same example. Okay, the IP is 10.0.0.1, 10.0.0.2, 10.0.0.3, and 10.0.0.4. Okay, this PC, whenever go outside, we have assigned some pool of public IP 1.1.1.1, 3.3.3.3, 4.4.4.4. Only 3 public IP I have assigned. Okay, guys. So as I said, dynamic NAT is using first come first serve. Okay, suppose this is the internet, and there is any PC, whatever it is. So whenever if this guy PC1, this is PC1, 2, 3, 4. If PC1 want to go outside, he have initiated the traffic. Okay, he will initiate the traffic, and traffic come to the firewall. Okay, so he will get a one IP. He will assign to this IP. He will get this public IP assigned to this, and he will go to the internet. Okay, guys. Okay. So then if suppose PC2 will want to go outside, want to go internet, so he will initiate the traffic. He will come to the packet will come to the firewall, and it will get the one public IP from the NAT pool. Like this public IP will assign to this, and it will go to the internet. That is clear. Okay. Even once if this user come, this PC come, and he want to get a google.com, whatever you want to assign, he want to access the internet. Once he will initiate a traffic for google.com, he will NATed with this IP, this available IP. Okay, in this group there is this last IP is available. He will get this IP, and then he will able to go to the internet. That's fine. Okay. When the fourth one would try to access the internet, there is no available IP, right? There is no available IP in this pool. What would happen? He has to wait. He has to wait till any of the IP would get available. Like any of the user will disconnect his connection, then only that public IP is going to be available. So then once he will initiate the traffic, then he will get, if any IP would be available, it will assign to this guy. Otherwise, he has to wait. He is not able to go to the outside because there is no public IPs available at that time. All are engaged. So that is called first come first serve. Okay. So dynamic NAT is actually out of fashion. It is not much used because it is very much costly. Why? Because we know that public IP is very much costly. So for like if we have a if we have a 3 public IP here, so this 3 public IP is only going to use by only 3 PC. Only 3 PC, guys. The rest has to be wait, because there is no available IP could be after that. So if you have 100 of users or thousands of users in your local LAN, okay, if you have thousands of users in your local LAN, how you can provide? Did you do a static NAT? Did you get a some pool of IPs? That is very much costly, right? That is so. There is a new technique. It's called dynamic PAT. Okay. Before going to dynamic PAT, I want to explain. Slide. Dynamic NAT is also a unidirectional. Dynamic NAT is also it's a unidirectional. What is the meaning of unidirectional? Means it can only initiate a traffic. This is internet. This is my inside zone. This is a PC. It can only initiate a traffic from the inside. No one can initiate a traffic from the outside for this. How and why? I will explain it later. Okay. So dynamic NAT is a unidirectional. It can only initiate a traffic from the inside. Okay. But for the static NAT, traffic can initiate from the both sides, both ways. That is clear, guys, right? That is very important for a netting concept. Now just learn about the dynamic PAT. In the dynamic PAT, there are 2 scenarios. I'm going to explain the first scenario. Like we have one PC. This is a very important NAT. We have one PC, okay? And suppose we have one LAN, okay? And we have this is a LAN, complete LAN, multiple PC we have, multiple PC. But I'm taking the example of 10.001, 10.002, 10.003, 10.004, okay? These are the PC name. So this is my inside zone. And this is E/1, this is E/1/2, and this is my outside zone. Okay, this is internet and whatever it is, internet. So, so guys, we know that as in our topologies event, public IP is configured at the outside of interface. That is clear, guys. Okay, for any firewall, if it's connected with the internet, So that outside zone, outside interface of that firewall would be get a public IP. We know that. So this interface is actually has a public IP. Okay, guys, because it is connected directly with the internet. All right, my inside zone or DMZ zone, whatever, those are actually having a private IP. Okay, that is clear, guys. Anyone have any doubt for this? Public, the IP which the interface which is connected with the internet, that is a public IP. So suppose my private my outside interface, this is my outside interface, is actually have a IP of 1.1.1 as per the example. Okay, suppose this one has a the IP of my outside interface is a public IP 1.1.1. So I'm talking about the scenarios one that for dynamic pad, whenever the PC, I have configured such kind of configuration of firewall for dynamic pad that whenever any PC, any of the PC try to go to internet, it will get this interface IP. This outside interface public IP would assign to all over my LAN, whatever the LAN. How if we have 100 of users even, whenever they want to go to the outside, it will assign this IP, public IP, and they will go to the outside. Whatever any of the traffic coming, it will get the only one this IP. It will go to the internet all the time, simultaneously. No need to wait. No one. If it is 1,000 of users even, okay. If those want to go outside, whenever they want to go to outside, the outside interface IP of a firewall will get assigned, and that public IP outside interface of public IP will get assigned, and they will be able to go to the outside. Okay. This is the one scenario, guys. If we have 1,000 of users, I have configured that whenever those users will go outside, it will take my outside interface of public IP, and then it will go outside. So see that only one public IP, we are able to manage. We are able to send thousands and thousands of users to connect to the internet. Only one public IP. So I'm using this like this 10.001 PC1 has initiating a traffic. Okay, guys, and he just want to go google.com, whatever it is. Okay, and the source IP, whatever this IP, this is source, right? The source IP would get this public IP. So I'm for the scenario zone, I'm explaining what are the packets actually. So like suppose this is original packet, guys. Okay, original packet. I'll explain everything. And if you understand dynamic pad, you will understand everything. So what would be my source IP, guys? Source IP is there 10.001. Okay, that's fine. Destination IP, it is anything like google.com, whatever it is. So I'm just keeping 2.2.2. Whatever the destination IP, I don't care. Okay, what is my okay? We know that, as we know, whatever the traffic, any traffic would initiate it, there would be a source port even. We know that we have talked about it, right? Source port. Okay, so source IP is 10.001. What is the source port? As I explained about the transparent stateful firewall, right? So it could be if any traffic would be initiated. If this is a PC, this is firewall, this is the internet. If any PC will initiate a traffic, what are the stuffs? One is source IP. Okay, I suppose source IP is 10.001. One is source port. Source port, as I explained already, it will take a random port. Like 1024 till 1024, it is well-known port. After that, it was a random port. So suppose it is taking a port number 2432, whatever it is, random port. And then destination IP. Destination IP suppose 2.2.2.2 and destination port number, whatever it is, like 443. So that's the actual packet, guys, right? That's the actual packet. So dynamic pad is actually working on source port. Okay, so this is a specific source port where the connection, it is a connection oriented. My firewall is a connection. It's maintained a state table. So from checking a state table, it will start, segregating or differentiating the new connection, everyone. So let's try to understand, guys. So like suppose here we are going to take up two examples for one PC1 and PC2. Okay, PC1 has IP of 10.001, PC2 has IP of 10.002. Now let's come. What would be the actual packet, guys? Okay, so here the first example. Okay, original packet, OP, and translated packet, TP. Okay, guys. So here is the one thing: source IP and then destination IP. The source IP for packet 1, 10.001, destination IP is suppose 10.002. That is fine. And translated packet, source IP, guys, just try to understand, is now, it will take as I explained, the firewall interface IP, right? So whoever is going outside, it will take my firewall interface IP, this IP. This IP has IP of 1.1.1, right? So what is my source NAT IP, guys? This IP will NAT to 1.1.1.1. And destination IP is same 2.2.2.2. Just try to understand what I'm telling. Okay, there is one more packet here whose source IP is 10.0.0.2. He's also initiating a traffic for 2.2.2.2, suppose like google.com. Okay, now the source IP of this PC is also the same, right? 1.1.1.1. And destination IP is also same 2.2.2. How my firewall will distinguish? If suppose there is one more PC 10.0.0.3 has initiated a packet. This is source IP. Destination IP is 2.2.2.2. And it also get natted with the source IP 1.1.1 because whoever initiating the traffic, it will take my firewall interface IP, right? It will take my firewall public interface IP, like it is 1.1.1, right? This all will take this interface IP. So third PC will also get the same IP. It is also initiating the 2.2.2. Let's suppose a google.com. Okay, then suppose if other PC also came and it also initiating a google.com which has IP of 2.2. Suppose here its source IP also changed to 1.1.1 and destination IP is same. So you can see that translated packet, all packets, all different PC are initiating the connection, and it is the translated packet is all at 1.1.1.1, and they should say same. Can't my firewall get confused how this phenomena is happening? It is netting with the help of port base. We know that, as I explained, the packet we have on source IP, we have on source port. Source port would be random. So whatever the traffic is initiating, they have their random source port. So for PC1, their source port would be something random like 3461, whatever it is. For this packet could be 4561, whatever it is. For this packet 3323. For this packet source IP would be 5631, whatever it is. So this source port is actually playing a very important role for doing a NATing. So that's why it's called dynamic PAT. It's a PAT. Okay, port address translation. What is PAT? Port address translation. Okay, guys. So that is happening on behalf of with the help of port translation. That's why it is called patting. And guys, patting is also a unidirectional. Unidirectional. What is unidirectional? Means it can only initiate a traffic from inside. Okay, from the inside zone, from inside to outside. Even from the DND also, but one way. Only traffic will go one way, not from the outside. Why anyone could ask questions? I will explain later on. Tomorrow could be. But that's how patting actually helps. So with the help of PAT, guys, how the patting is helping. So we know that with the help of PAT, even we have a 2,000 users. Okay, 2,000 users with the help of one public IP, we can able to send all users to internet. Okay, if there would be no PAT technologies, what would happen? For sending a 2,000 users to internet, we have to be used 2,000 public IP, right, guys? So that is why we need a PAT. So patting is one IP is capable of sending more than 2,000 even. Okay, it has some kind of threshold, but okay, but let it be. Even so, I have explained the scenarios one. There is a one more scenario, the same thing. The scenario is what? This is my firewall. This is the internet. This is my outside interface. And here is a public IP is 1.1.1.1. Okay, this is my inside zone. And there is my PC. All are the PC 10.111, whatever, guys. Okay, same thing. Okay, these are the PCs. Okay. Okay. So, guys, the thing is that, so what is the second? It's nothing much different. I don't want that it will use my this public IP. I don't want. For the dynamic PAT, whenever those PC will go out, I don't want they will use my interface, my firewall interface IP. So what I will do, whatever this 10.001, whatever the 10.002, even full subnet like 10.0.0.8. So let's say if this all subnet, whenever they will go outside, I will give any public IP. I will assign that it will translate to 3.3.3.3. I will give only one public IP. Okay. So one is it has to be used the interface IP. Okay. And one is either you can give all subnet to any free IP, any free public IP. So if they will go outside, just assign one public IP, configure one public IP with this subnet. So whenever the any IP of this subnet belongs to this subnet, whenever those go outside to the internet, those can only use one public IP, only one public IP. Okay. So here, no need to use from interface IP. So that's all depend. If you want to use my interface IP, firewall interface public IP, it can. Either you can get, if you have a free public IP, you can give. So that if you have some small office where you don't have a much public IP, because public IP is very much costlier. So that kind of scenarios, you can use your public interface IP. Either if you have a big company, if you have a multiple free IP, so you can assign one free IP to any of the subnet which you want to forward to the internet. Okay. So what would happen? Like I have a 2 PC. Okay, guys. And if this PC has a source IP 10.001, this one is a 10.002. Okay. And they have a connection with this firewall. So if suppose its source port is also 2222 and this port is also 2222, suppose it's initiated a connection to the firewall to going to the google.com same time. Okay. Like this is already maintaining a connection. It is already going to the internet. But meanwhile, if some other PC came with the same source port going to the same google.com, at that point of time, your firewall will not forward the traffic. Your firewall will set as some reset or some kind of, it will reject the traffic. Okay. It will reject it and just ask it to initiate a connection again. Okay. So then at that point of time, your PC will again, reinitiate the traffic. At that point of time, your source port will be changed. Okay. So that point of time, your firewall will have an intelligence to drop the connection and it will ask your PC to initiate a connection again. So again, your PC will reinitiate the traffic and it has some different port number, like whatever 3333, and then your firewall will forward the traffic. Okay.